Our next speaker is Nagihara, and they'll be speaking about Mare Imbrium, a window into the PKT mantle.
Hello. I hope everybody can hear me. So yeah, I'm gonna try to, along with my co-presenter Bob Grimm, to make a case to send the CLPS mission to Mare Imbrium. So the science objective is to determine whether or not radionuclides in the PKT are fully partitioned in the crust or not. So so during the early evolution of the moon, so somehow the radionuclides, heat-producing elements, ended up pooling in the region of the near side, which now we call PKT, right? But we still don't know if all these incompatible elements were efficiently fully partitioned into the crust, or we still have quite a bit left in the mantle. So that will kind of, changes our understanding of the evolution scenario of the moon, right? So that's what we want to investigate. So that objective can trace back to the original the skin report in 2007, and also that was reaffirmed by the leak study a couple of years ago, to characterize the thermal state of the interior and elucidate the workings of the planetary heat engine. Next slide, please. So the rationale for going to Mare Imbrium. So the one way to check or test whether there's some heat-producing elements left in the mantle under the PKT crust or not is to actually try to measure the heat flow that comes out of the mantle of the PKT, right? But we have no way of actually measuring the mantle heat flow directly, but we can measure the heat flow out of the surface of the moon, right? So, but the problem is if you measure heat flow on the surface of the moon, so we are also measuring the heat produced within the crust as well, right? So that's why one way to go at the mantle heat flow is to go to a place where we think the crust doesn't produce much heat. Then in PKT, then there's one place you can do that. So that's Mare Imbrium. So the Mare Imbrium, as you can see from this thorium map from Kaguya mission, so has a big low blue spot there of the thorium concentration. This is because the basin forming impact has actually excavated much of these heat producing element rich crust, right? So also because of that, the crust there is thin. So that's why we expect that the Mare Imbrium is a unique window where you can actually go there and measure the heat flow at the surface. Then that should be more or less close to the heat flow that comes out of the mantle, right? But we still need to know. So if that heat flow, let's say we can measure the mantle, estimate the mantle heat flow out of the Imbrium, but we still need to know if it's any higher or hotter or the colder than the areas outside of PKT, right? Then fortunately, so we are already going to Mare Crisium on the CLPS mission in 2023. So that's the land that has been already selected from Firefly.
Okay, and we're going to need to move on.
I'm sorry.
Yeah, we're running low on time. Can you finish up?
Yeah. So yes, I have only 2 more slides. So I still have a minute, right? So. Right? Minute and a half, I guess.
We're a little over time. Go ahead and finish up.
Really? Okay. Sorry. Okay. So anyway, so that's why we can compare that results between the Crisium and the Imbrium. Then so that will allow us to see if the Imbrium mantle heat flow is any higher. So that also add more value to the Crisium mission as well. So go to the next slide, please. All right, so since I'm out of time, so I'm not going to talk too much about this. So we have these instruments that measure heat flow, and also magnetotelluric measurements. Then by combining two measurements, then we can actually get a temperature and electrical conductivity and the compositional profile down to the upper portion of the mantle. Okay, please go to the next one then. All right. So that's why we just need a static lander. Then we just have to be careful about selecting a landing site to avoid any major rocks and so forth. And then again, the payload mass and the power requirement is small, so that's why you have plenty of room for other payload as well. Okay, thank you.